Hi everybody, Professor Gassimi here. In this week's lecture, it's all about JavaScript and JavaScript essentials. Now, as usual, I would like to start off the lecture by giving you a set of associated readings that are not only available here on the screen, but are also available in our course calendar. These readings are a great way for you to take some of the concepts we're going to touch on in the class and to go into significantly more detail if you need it. There's also wonderful tools and interactive exercises that you can access on these readings that I've shown here. So let's get started. What is JavaScript? Well, before we dive into JavaScript, let's remember the two things we've covered already. Up to date, we've spoken about HTML, which is the markup language that we use to structure and give meaning to our web content. So we have a document, we want to define some paragraphs, we want to make some headings, inject tables, images, videos, etc. That's the domain of HTML. It's like the skeleton of the website. We also covered CSS. This is the language of style. It governs what is the HTML going to look like, how is it going to be padded, are there going to be borders around the boxes, are we going to stretch the images or not, what's the font colors going to look like? All those sorts of things that govern the aesthetics of the document are controlled by CSS, which we covered last week. Now, you probably noticed last week that we went into a lot of detail about HTML and CSS, and there was a reason for that. If this is your first time seeing web programming, HTML and CSS are actually the two components of web programming that I would argue diverge the most from what you would typically see in a programming class, like for C++ or Python or things of that kind. We're now going to be moving on in this lecture to JavaScript, which is actually going to look a whole lot more familiar to you if you've dealt with other programming languages, because JavaScript is a scripting language and it has a lot of the beautiful functionality that other scripting languages have. And what's really great about it in the context of web development is that it allows you to dynamically create and control content, multimedia, animate images, make your website react to actions by users. Anything you can sort of think of, JavaScript can do it in the context of the web. And once we've gotten through the JavaScript lecture today, we'll have actually covered the three main language components of front-end development. So what can JavaScript do? Well, I think the right way to illustrate it is with an example that we'll start with. And some of what I show you here is going to be familiar because there's HTML and CSS. And then we're going to have some new content that's JavaScript. And the things there are going to look a little confusing here at the start of the lecture. But my objective is by the end of the lecture, if you came back and looked at this simple example, everything would be totally obvious to you. So let's get started by just taking a look at the HTML. And that's what's here at the top left of the document. And what you can see is we have an opening and a closing HTML tag, as we discussed in the last lecture. And within this HTML tag, there's two sub tags. There's the head, and then there's the body. Now within the head, we have all the kinds of data that we don't necessarily want to visually appear on the website, but that's important to govern what's going to occur, such as setting the character encoding, making a title for this page, and putting a link to a style sheet. That's what we're showing here on the right, as well as a link to a script that we are going to show here at the bottom. And we're going to go through that in a minute. Now within the body of the document, that's the visual content that shows up, which is displayed here on the bottom right corner. It's pretty simple. There is a div, which we've given a class called container for styling later. And within that div is a paragraph. We've given it an ID button, and it contains some text, player1:test. So this HTML structure governs the document that you see here on the bottom right corner that the GIF is kind of clicking on and interacting with. Let's take a look at the CSS next. That's here on the right. You can see it starts with a description of how we want to style the body and the HTML. So that's sort of what's the default we want to use for the body as well as the HTML document itself. And we said, hey, let's set the background color to gray. And that's the reason why down here you can see that a lot of the screen color is gray. But within the container, we set the background color to be white, which explains why there's this block of white within the gray. We specified a width, which was 50% of the total viewing width. And you can see that white box is about 50% as wide as the total area that's spanned by the gray here. And with respect to the button, and specifically the button ID, we indicated some other style features, such as moving things to uppercase, center aligning the text, making a fancy border, and so on and so forth. Okay, now the piece that we really want to talk about here is here on the bottom left, which is the JavaScript. And the JavaScript is what's allowing us to do what you've been seeing playing over and over in this GIF, which is when this button is clicked, a prompt appears up here at the top of the screen to enter a new name, which we type Dr. Ghassemi, and you can see that this updates. So the web page is reacting to things that I'm doing, and that's what the JavaScript is responsible for. The way that you write JavaScript to do a function like this is what I'm showing there on the bottom left. And in this case, what we're doing is we are creating a constant variable called para, short for, or long, I should say, maybe for this p tag, paragraph. And we're actually going to our document, which is a object representation of both the HTML embedded with the CSS together that's created by our browser. And we're querying the document for a p tag, okay? And if you were to query this document for a p tag, you're obviously going to get this one with the ID button, right? And then what we're doing is we're coming to this p tag that we've sort of selected with the query selector and is now pointed to by the para constant. And we're adding something called an event listener, which is basically sitting and, as the name implies, listening for an action done by the user, like a click. When the click happens, it calls a function called update name, and that function is defined down here, which does two things. It first collects a variable called a variable called name, which is populated through a prompt. Enter a new name. That's the box that keeps popping up right up here. It finally takes the result of that prompt and it stores it in the p tag, which was referenced by this para constant. It stores it by sort of updating the text to say player one and then substituting the name into that text. And that's how we get this sort of reactivity you see down here on the bottom right. Now, as I mentioned, this very, very simple example, some of the components here we've not gone through yet, but I wanted to step you through right here at the beginning how a HTML, CSS, and JavaScript front-end web application looks at its absolute simplest. When you're working on things like the homework or your own web projects, you will have a skeleton that starts probably just like this as you do the work. Now, as we alluded to in that previous example, JavaScript, what makes it very powerful is that it can react to users' actions through events. And these events are fired to notify the code of interesting changes that may affect the code's downstream execution. It could be a mouse movement, it could be a key press, it could be any sort of thing that the user does to interact with the site. It could even be related to the amount of time that the user has spent on the site. I'm showing here on the right-hand panel another example of some JavaScript that helps us capture interesting events like key presses. You can see here that we could have a constant variable called log, which comes from, let's say, an element called log. So we might have a somewhere in an HTML document that I'm not showing you here, an ID tagged element called log. And we might want to add an event listener to that that's specifically looking for key presses. And we could then define specifically what we want to do when the key press occurs. as indicated by this log key function, in which case we'd want to take the particular event associated with the key press and grab the key code from it. And that's what I'm showing you down here. Basically, I'm pressing a bunch of keys, and every time I press one, I'm printing that to this text context area. Now, one of the things that's really neat about JavaScript is not just that it allows you to do scripting like C or Python or many other languages would, but it actually has a really rich set of application programmer interfaces or APIs. And APIs are basically just ready-made sets of code building blocks that do useful things and make your development cycle faster. There's two varieties of these APIs. There's some that are built into your browser. And I'd like to go through a selection of those first that are, I think, the most important ones. The first is the document object model, which we will speak about in a minute. This effectively allows you to manipulate the HTML and CSS to dynamically apply new styles to your web page. So in the last two examples I showed you, in both cases, we actually used the document object model. There's also other APIs that you can access that are made available through your browser, such as the geolocation API, which is how browsers request information on where you are, whether you're in East Lansing, Tokyo, wherever it might be. You can use this geolocation API built into the browser. If you want to do animations, 2D, 3D, or draw beautiful things, you can do it using Canvas and WebGL. There's APIs for audio and video, and things that allow you to extend the audio and the video that's either being to display it on your website or to stream it to others who might have made a connection with your website. So there's lots of great APIs that are built in that allow you to flexibly build tools. So we spoke about document object model, and I mentioned that we've used the document object model actually in the previous couple of examples. Well, I wanted to make it clear that all this document object model is a object representation of the HTML and CSS. So basically, when you give HTML and CSS to your browser, it takes it, it parses it, and it turns it into something like a long object that you can then navigate through with JavaScript, make changes to, and you get changes in what's visualized to the user on the front end. You might, for example, take a document that's HTML and CSS and turn it into a document object model like what you're seeing on the right, where you have a top-level object called document. Within that is a root element HTML. Within that are two sub-elements called head and body. Within head, there might be a title followed by some text and so on. Okay, but the thing you need to know about the document object model is that all the properties, methods, and events available for manipulating and creating web pages are organized into this object. And it's manipulation of that document object model that allows you to, with JavaScript, dynamically change what you see on the front end. So we spoke about some of the APIs that are made available through the browser. JavaScript also allows access to third-party APIs that are not built into the browser. This is where you run off to some foreign web server, you grab some code or information from some other place on the web and incorporate it in. A common one is the Twitter API, which allows you to, for example, display your tweets on a website. Google Maps has an API so that you can embed a map on your website, and so on and so forth. Don't worry too much about APIs from foreign sources yet or third-party sources yet. We will actually have a lecture where we'll talk about how you embed those in your website later. One thing I really want to emphasize as we are introducing JavaScript is that the console is your friend. If you right-click your screen on the web browser and you click Inspect, you will pull up the JavaScript console through one of the tabs here. And this console is going to give you an idea for how you navigate the document object model. I'm going to show you an example here now. If we opened up the console and we type in document, you can see it gives some options for components of that document object. We could, for example, use the query selector to select on my website here the container that has this introductory text about me. And then we could change the style by kind of dotting our way through it and finally updating some of the properties, such as the style display to none, which eliminates it. So I wanted to show you that because as you're learning JavaScript, one of the ways to obtain an intuition or to solve problems is to open up your website on the console or to open up other websites on the console and kind of play with them and get an understanding for how they work. So JavaScript is an interpreted programming language, and what this means is that for the most part, there are some nuances, but for the most part, it runs from top of the code to the bottom of the code. There are some important exceptions, which we will talk about a little bit later. But as you're writing JavaScript, just know that it runs from top to bottom. If you declared your variable before you added the event listener, your code would work without any problems. But if you tried to add the event listener for a click before you declared the variable, you would get an error of some kind in your console. Now, JavaScript can be used on both server as well as client-side applications. For most of what we're going to be doing in this class, JavaScript is going to be our client-side language. It's what we're going to use to control dynamically what gets displayed in HTML and CSS. But there is, of course, a way to use JavaScript as a backend tool as well, and that's actually what Node.js is. Again, we won't be using that in this class, but wanted to make you aware of it in case you weren't already. So how do you add JavaScript to your page? Well, it's pretty simple. There's a couple of ways to do it. One of the ways, which I think is the best, is for you to reference it either in the top here of your head through a link or by including a script tag at the bottom, like I'm showing here, right before your body ends. If you do this, and as long as you're pointing to the right JavaScript location, then you will pull the file and it will be integrated with your HTML and everything should work fine. Another way you can do it is you could take this same JavaScript, which we have here on the bottom left in a separate pane, and you could actually include it within a script tag directly, and it would also work. The latter is considered bad practice. That is, including your JavaScript internal to your HTML document is not really the best thing to do. It's better to keep those things separate for readability of your code, so people don't have to context switch between languages. There's actually an additional way that you can add JavaScript to your page, and that's inline using HTML attributes. So for example, you could come here in that very simple code block of HTML I'm showing on the top left. You could have a button, and this button could have an attribute called onClick. And within this onClick, you could summon a JavaScript command of something. You could console.log, you could alert, you could do anything. You could add two numbers, whatever is possible in JavaScript, you could include between these quotes, and JavaScript would execute that. In this case, we're calling a function createParagraph, which is defined down here. This is not good practice because, again, you don't want to pollute your HTML by interspersing JavaScript within it, and especially not by doing it within the tags. It becomes a readability nightmare very quickly. You should ideally, as I had mentioned, keep your JavaScript in a separate file. So instead of doing what I'm showing on this page where there's an onClick that calls a particular function we're interested in executing when that button is clicked, you instead could add an ID here, bind that ID to a JavaScript variable, and then create an event listener on that ID by adding an event listener that will listen for clicks and run the exact same function you were interested in anyway. So this is an example of the right way to add the interactivity using JavaScript as opposed to hard coding it into certain functions. I emphasize this because if you Google around for answers to questions, even on places like Stack Exchange, you will see suggestions that include putting your JavaScript within the HTML documents. So there's a couple of considerations to have in mind when loading JavaScript. If you load your JavaScript before your HTML document has finished loading, like your browser is in the process of reading HTML and starts reading in the JavaScript and executing it, you can get these really devilish errors that are super confusing. Like your code looks correct, you're not getting any explicit errors, but everything is just breaking. That's what I mean by a devilish error. The solution to this problem is to always add the defer attribute to the end of the tag that you use to import the script. That is the contemporary and correct solution to the problem. I'm showing an example of it down here on the bottom left. I have a script. I point to the location I want to import the script from, in this case, javascript.js. And you can see I have an attribute within that script tag, defer, that basically says, wait for all the HTML to finish loading, and then and only then do you run the JavaScript piece of this. This will prevent those errors. There's also an old-fashioned solution to this problem, which I used in one of those earlier examples, which is to actually put the script at the very bottom of the body, right before the body close tag. You will see this referenced as a solution on websites, but actually the contemporary way to solve the problem is actually to use this defer attribute that I referenced here on the left. And I sort of lied to you when you said you should always use defer, because there are circumstances where you may not want to use defer, but instead use an attribute called async instead. It really depends on whether you need guarantees about the execution order of the scripts that you're calling. What I mean by execution order is if you had 3 scripts that you wanted to import, script 1, 2, and 3, and you used async, there's no guarantees that one script will finish importing and running prior to the other. If that's okay, because those 3 scripts have completely disjointed functionality or do different things on your website, that's great. You can asynchronously load them and that will give you a performance improvement. But if there are components of script 2 that rely on script 1 being run first, for instance, script 1 sets up some global variables or something like that, you would definitely want to use this defer attribute, not async. Okay, there's obviously an implication here from a timing perspective, because if you use defer, it's going to wait until all of the HTML is parsed, as indicated by this green line, before you execute the JavaScript piece. Just keep in mind that depending on exactly what you need to accomplish, you can choose one of these two. I would say for safety's sake, use defer. If performance becomes an issue, you should investigate when to use async. So how do you write comments in JavaScript? Well, it's pretty straightforward. You have multi-line comments, as I'm showing here on the right-hand side. It's a slash star, some text followed by a star slash. Then you have single-line comments, which are just indicated by 2 slashes. The main thing I want you to get from this component of the lecture is that JavaScript is a scripting programming language, and it allows you to implement the more complex features that you see on the web. JavaScript can store values in variables, it can perform operations on variables, it can respond to events, and a lot more that we'll talk about here in a minute. JavaScript also allows for the use of browser and third-party APIs in your web application, and actually those browser APIs are, in my opinion, what really makes JavaScript super powerful. JavaScript can be placed either internally within your HTML documents, or it can be linked to externally using the script element, as we showed multiple times. You should, of course, always link to it externally using script, unless you have a very good reason not to. And there are ways to include attributes within your script tags so that you can bypass kind of the devilish problem of script blocking when you're loading JavaScript in your HTML documents. So with that complete, I'd like to now move on to the next component of this lecture, which is about an interactive JavaScript example. So what we'd like to do for the next few minutes is learn the basics of JavaScript by going over a number guessing game together. This is going to in the course of learning how to build this animated GIF you're seeing on the screen for the game, we're going to cover all the basic components of JavaScript. So this number guessing game that you're seeing is pretty simple. We want to have some number between 1 and 100 that gets generated, and then you want a user to come in here. They want to enter a guess that they might have, submit that guess, and then be told some information about whether they were right or wrong and whether their guess was too high or not. We also want to keep track of the number of guesses they did. And maybe if they get to too many, let's say 10, tell them that they lose. If they do it right, we want to tell them that they win and allow them to restart the game. Okay, well, the prerequisites before you ever write JavaScript, in the case of this game or any project you're working on, is to always try to set up your HTML and CSS first. So in this case, if we wanted to build the little number guessing game that I'm showing there on the bottom right-hand side, we could set up the skeleton and the style, those two important first pieces that we covered last week, using the following HTML and CSS. And a lot of the stuff here you're familiar with already, right? There's a head tag, there's a link to a style sheet, there's a script for the JavaScript that we're ultimately going to use, but it's empty right now. We have this defer attribute so that we make sure that the JavaScript loads only after the HTML page is parsed. Within the body, we have the components that you're seeing there visually on the bottom right. We have the number guessing game in a header tag. That's why it's big and bold. Then we have a small paragraph explaining the rules of the game, which you see here. Then we have a div, which we've given a class label called form. And within this, we have a input that is for a type text. That's this box here. We have another input that's of type submit. That creates a button that you're seeing here. And then we have a label that shows up to the left of the input for some instructions on where they should enter the guess. Now you also see that we have, as we've gone through this, been careful to assign classes and IDs to these items up here, even though we don't have anything in our CSS that corresponds to them yet. You're going to see why we did that on the JavaScript side here in a minute. But note that we have class labels assigned to a lot of these, or IDs assigned to these. We also have down here a results area, results paras. So these are paragraphs where the results are going to be shown. And there's nothing in them right now, right? It's just empty. But we want to populate this using our JavaScript based on what people submit as guesses later. So we've placed it here in our skeleton to begin with and given class labels that we can use to access this with JavaScript. Now, the first thing that we'll need to know if we want to build the JavaScript for the game is a little bit about variables and constants. Okay, so variables are basically names for values like in any other programming languages, and you create them with the keyword let followed by a name for your variable. So for example, we have here let random number equal, and then we've called the math object, and we want the floor of math.random. So this just gives us a random number between 0 and 1. We multiply it by 100, add 1, and we get a random number that we're going to use for the number guessing game. We are then, in this case, printing to the console of JavaScript after we run this. The correct answer is, and then we put the random number so that we know what number was drawn here. And you can see here down in my JavaScript console, that is in fact what gets printed. I'm showing you console.log here very early as we go through JavaScript because as you're debugging your code, inserting console.log is like your print statement in Python or your print statement in C and whatnot. It's a great way to, if you're going to run a long, complex piece of code and you need to view what the contents of a variable is or how something is working or its state, is to print it using console.log, as I'm showing you here. Okay, well, within JavaScript, there are not only variables, but there are also constants, and these are declared using const. Unlike variables, you can't change their value once you've set them. Constants are made to store a reference to corresponding tags in HTML in our case. So notice that up here in the HTML, which I'm showing in the top part of this panel on the right, I'm showing you once again that there were all these classes that I assigned, even though I didn't style them in my very simple CSS document, right? Well, the reason I did that was because down here in JavaScript land, I wanted to create these const variables that were going to be a reference to those particular elements within my HTML document. You can see here, for example, the first one, guesses, this constant, goes to the document object or document, and then it selects a method within document. It has a method called query selector that lets me basically query this document for, in this case, a class, as indicated by the dot, called guesses. So it's going to run through this document. It's going to grab this particular paragraph tag and its contents. And now it's bound to the variable guesses. And the same is true of all of the other consts that you see down here. Now, in addition to these things to bind to the various components I'm going to use to build the application, I'm going to need some internal variables too. Let's initialize with a guess count, because if they guess too many times, we want them to lose the game, and we'll set that to 1. And then we're going to want a reset button. And we're going to just declare that variable, but not give it a value quite yet. Now, JavaScript has functions like other languages do, and you can define a function by using the keyword function followed by the name with parentheses put after it. Okay, so I've showed you an example here on the bottom left. What we have is at the very bottom of the code block I showed you previously that had the guess count and the reset button, I've appended a very simple function called check guess. Okay, and all the check guess does is it calls console.log and says, I'm checking the guess. Now, after you've run this JavaScript block, if you come down here to your console, you can call the function by just typing in check guess, open close parentheses, and it will print, I am checking the guess. Now, obviously, when people are playing the game itself, they're not going to have to open your console and run this. Just like we saw in the introduction of this component of the lecture, there's a way to bind functions to particular kinds of events or activities that are performed by the users, which we'll speak about. JavaScript also has some operators. Again, like most programming languages, these are arithmetic operators that are available in the language that cover addition, subtraction, multiplication, division, remainder, and exponentiation. And I'm just showing myself playing around on the console and how it reacts as I do some very simple math there. A note about these operators as well is that strings can be operated on by numerical operators. So meaning you can add strings to concatenate their value, like I'm showing here on the GIF on the right-hand side. I can take the name and the title. I can add those two strings together with a little bit of white space, and I will get a string that is presented with my name kind of backward. JavaScript also has some conditional operators to evaluate if statements are true or false, just like other procedural programming languages. So if, else if, and else statements can be used to take actions depending on the outcomes. I've shown you a little template if statement that you have down here in pseudocode. And I also wanted to show you some of the operators that can be used within the if statements for those conditions. Something to note here is that JavaScript has a double equals comparator, but you should always use triple equals because triple equals is a strict equality check. Double equals is a loose equality check. And what that means is that a loose equality check might conflate the string 500 with the integer 500. A strict equality check would not confuse that. So as a default, you should always use the triple operator when you're checking things. And a lot of these other operator statements are things you're probably familiar with in other programming languages. I only highlighted this triple operator because it's a place that you might trip. And of course, these operators and the conditions sort of support logical operations and, or, and not. I'm showing you an example of how you would include some of those logical or operators here, as well as an and operator here. So let's bring together some of the things that we learned here by writing a function to help us check the guesses that the user of the game inputs. So you can see here we have a function, the same function, check guess, that we had before. And within it, we have a constant that has the user's guess. We obtain this by going to the guess field. This is something we bound to earlier, remember, with our query selector. We grab the value from that, convert it to a number, and it's now in the user guess. If this user guess count is equal to 1, then what we want to do is we want to show previous guesses here, okay? Because as long as there's one guess or more, this text has to show up. Okay, that's great. Well, then the next thing we want to do is we want to add the actual user's guess followed by some white space. And just for good measure on the console, we can log it. Now, if the user's guess is actually equal to the random number that we had selected earlier, we want to tell them, congratulations, you got it right. And we can do that by updating the last result.text content to say this, and by changing the background color to be green. Okay, now similarly, if they get it wrong, so if they don't get this right and they're not at the end of the game, which is the second condition that we'll cover here in a minute, then we want to have the text content show wrong, and we want the background color to be red. We also want it so that if the user's guess was less than the random number, we show the last guess was too low. And if it was greater than the random number, we want the last guess to say it was too high. If the user tries too many times, we don't want to say congratulations versus wrong, like we're showing you here on the top right, but we may just want to show them game over because they've tried too many times. In which case, we don't necessarily want to change anything about the color here, the background color. We can keep that, whatever it might be. But we do want to wipe out the hint that would say whether the last guess was too high or too low. And that's what this setting this blank does. Also, if we win the game, or if the game has come to an end, we'll want to do some stuff to help reset it, right? And so we should write down here that we're going to have a function to take care of that, which we've not written yet. Here at the bottom of that nested if statement, we have some housekeeping, like incrementing the guess count, setting the guess field's value to empty, and focusing our cursor back on the guess field. So this is basically when you click submit guess, you might notice the cursor reappears automatically here. That's what this focus element does down here. Okay. So in order to get to the next step of this, which is to reset in the case of completing the game or failing it, we're going to need to employ some other assets within JavaScript. And the first of those is loops. Now, the basic tool for looping through things in JavaScript is the for of loop. And so if you declare a variable, such as in this case, the constant variable cats, and you store this with a list of items, Pete, Biggles, and Jasmine, you could, using this for loop down here, iterate through the items, substituting in for each of the cats in this list a string that combines the name of the cat along with the precursor string that's indicated by the myFavoriteCats variable here. Loops can also be used to iterate in a classical fashion. So what I'm showing you here is actually an example from the Canvas API, which I'm not going to go into in detail. What I wanted to highlight here was their use of a more classical for loop like what you'd see in C as an example. So you can have a for loop where you let I equal to 0, I less than 100, I plus plus, and you will iterate through this just like you would in C or another language of that variety. Okay, so bringing it all together, we need to use the knowledge that we just went over so that we can implement the additional functionality to reset the game that I'm showing there on the right. In this case specifically, we'd like it so that if we submit too many guesses, or if we get it right, there is an ability to restart the game, get a new random number, and keep playing. Well, in order to do that, the first thing that we'll need is to create that set game over function that we had called before, right? Within our earlier JavaScript function. The first thing that's going to do when we complete this is we're going to want to disable these two fields that we see here on the GIF. We don't want them to be able to submit guesses. We don't want them to be able to enter a guess. And these first two lines are doing that. They're disabling these two fields. We then want to actually create a button, right? That button appeared out of nowhere, as you can see here, right after things had completed. And that's what this does. We first create a reset button using the create element button here. We add some text to it, start new game, and then we append that reset button to the end of the document, which is what you're seeing here. Okay, and then we also take that same reset button and we're adding an event listener to it. And that event listener is for a click event, so that when this is clicked, some other function gets called, in this case, reset game, which we're showing down here. Reset game starts by resetting the guess counter to 1. And it comes and it takes all of the elements that are populated here. Previous guesses, the red box or green box with wrong or game over, as well as that button that we just created. And it selects them all. Why is it able to select them all? Because it says we'll go to all of the classes that are results paras. First go there to the results paragraph div and select all the P's within it. And so we're going to get a list of elements within this results paras here. And then for each of those, we're going to set them, the text within them, equal to blank. And that's what creates this disappearance that you're seeing here. We can then come to the reset button and remove it completely, because that button was not one of the paragraphs here. It was appended to the end of the body, as you may recall. And we can re-enable the guess field and the submit field. That's these two, the button here as well as the field. We set the guess field to blank and focus so that our cursor is over the guess field once again. Last items is we can set the last results background color to white. And we create a new random number and the game is effectively reset. There are some important considerations when using JavaScript that I'd like to take a couple of minutes to guide you through. The first of these has to do with the variables. If you look at examples of JavaScript online, you're going to see different ways to declare variables, and specifically, you're not only going to see let, like I've shown you so far in the lecture, you're also going to see people using the var keyword or using no keyword at all. Now, when JavaScript was first created, var was the only way to declare a variable. This examples that I've shown you so far has used let, which was created in modern versions of JavaScript to address some confusing issues that can arise when you're using var. And I'm illustrating an example of what makes the var declaration confusing there on the right-hand side. If you were to take the code that I'm showing you there and you were to run it, either in your console by pasting it all at once and running it, or by including it in a separate JavaScript file and running it there, you'd expect it to fail, right? Because I have a variable, my name equals Chris, but I've declared the variable down here. So I declare it at the bottom, but then I assign it a value at the top. So in a programming language that's sensible, you'd expect this to fail. But in JavaScript, if you're using var to declare a variable, it does something known as hoisting, where it will actually take this variable and yank it as though it was at the top of the document. So it treats this as though you declared it here at the top. Now, this can create errors that are very difficult to debug, and it makes your code more difficult to read. You actually want it to fail, in my opinion, if your variable declaration is after your assignment to that variable. So for this reason, you should always use let unless you have a very good reason not to. Another thing to note here about JavaScript variables is that they have a global or a local scope. So when you declare a variable outside of a function, it's called a global variable. When you declare it within a function, it's called a local variable. And so I'm showing you an example here. If we, within this if statement, which is a function, within this if statement, we try to let y equal to 5, and then we try to display the value of y using console.log, we would get an error that says y is not defined. It's only if we declare the variable outside of the if and then assign it that we'd be able to actually print it without fail. And this is because within the if statement here, it's being treated as a local variable. There are also more assignment operators than just the equals operator that I showed you in that example. We have plus equals, minus equals, times equals, divide equals, things that you probably have seen in other programming contexts. With regard to constants, I wanted to note that you have to initialize them when you declare them, and you can't assign them a new value after you've initialized them. And also, whenever possible, you should prefer to use constants over variables. So to be clear, if you were to create a constant called count, it will actually fail in your console. You can't just create a constant count without providing an initial value like I'm doing in the next line here. You can change this value only by basically recreating the variable by, again, writing out const count equals 1. So moving from const count equals 2, if you needed to re-declare this value somewhere later, you would do it this way, which is a bad idea. If you need to change values, you should use let, not const. But as you can see here, if I don't have the const in front of it and I try to update the value, I will get an error on the JavaScript console. Now, when you're working with strings, one thing to keep in mind is there are special characters that you might have to take care of. You can escape these special characters by using the / character like I'm showing you here. We had this string and we wanted to log it, and we wanted that little single hyphen to appear. The / is what helps us accomplish that. To join together your strings in JavaScript, you can use a different type of string called a template literal. And we saw an example of this actually in that interactive exercise around building the game earlier. If we have, for example, a constant variable called name, which has a value Chris, and then we have a greeting, we can set this greeting constant to have the name within it by using these hyphens. This is the one next to the tilde key, right? You can use these hyphens to indicate that you want to inject another variable within this string when you're doing the assignment. In this case, if you were to print the greeting, you'd get hello Chris, which is the hello followed by the particular variable you wanted to inject, which was the name Chris. When you're using arrays in JavaScript, the index of an item in the array can be identified using the index of method. So I think this is useful, especially as you're doing advanced programming operations. Just remember there is an index of. You don't need to write one yourself. You can add or remove items to the end of an array using the push and pop methods. So if we have an array here with parrots, falcon, owl, we can push cheep cheep, and you can see that the list increases. We can then pop cheep cheep, it comes off, and we have the original list once again. We can convert between strings and arrays using the split and join methods. So we can take, for example, that same array that I had here, we can join it with commas, then resplit it on the commas, we get the same thing back, or we could just join it with commas and we would get a string as the consequence. JavaScript has a really nice way of doing shorthand for your if statements called a ternary operator. It takes up a lot less code than an if-else block, especially if you have two choices for a true-false condition. It's a great use of code. I've shown you an example here. If we have a variable name, Dr. Ghassemi, and another variable fruit that we want to set dependent on the value of the name, we could do it by saying, well, if the name is equal to Dr. Ghassemi, then give apple as the fruit, otherwise give fig. And this is the way you would do that in JavaScript using the ternary operator. When you're dealing with loops, know that for loops, which is some of the examples we've shown, are not the only types of loops available in JavaScript. There are also while loops and dual while loops. While loops work similarly in JavaScript to the way they work in other languages. They follow and continue to iterate through the code that is contained within them insofar as the condition that's specified is met. It's up to you to handle things like iterations or break conditions. Speaking of breaking, if you do want to exit in a loop before all iterations have been completed, JavaScript has a break statement that you can use to break out of this loop if a condition is met. It also has a continue statement, which will not break you out of the loop entirely, but will rather make you skip anything else and just go back to the top to the next part of the iteration. So when you're using functions and want to support optional parameters, you can specify default values. I think this is really good programming practice because it helps hint to a person reading your code what the inputs to your functions should look like. So as part of good programming practice, I strongly encourage you to always specify a default value. In this very simple example, we have a function hello. It has an input parameter name, and the default value of that is Chris. And so if somebody just calls the function hello, they will get hello Chris. But if they call the function and specify a different name, they will get that particular name. It's also possible to create functions that don't have names, and this is useful under certain circumstances. I'll try to explain with the example there on the left. Let's say that you wanted to add an event listener to a text box that was looking for a key down, okay? And you need to specify what function you want to call when there is a key down event on the text box. And so you specify a function called log key. So you come up here and you have this log key, and you say that it takes an event that's generated when the key down is pressed, and it takes the event.key and it prints it to screen. We saw an example of this actually earlier in the lecture. Okay, well, this is a little bit long-winded, right? It might be nicer if we could sort of do this all within the same block where the event listener is. And this is where anonymous functions can come in handy. You can effectively come to the event listener, you can specify the event you're listening for, and then write out function event instead of just event, and specify the particular function you wanted to execute. In this case, it was the console log of you pressed and the event key. You will also see a further shorthand notation for this function event is just event with an arrow. And so if you're reading code online and you see an arrow here, just know that it's shorthand for this function statement here. JavaScript objects usually consist of properties and methods, and creating an object often begins with defining and initializing a variable of some kind. So, for example, if I wanted to create a JavaScript object called person, I can assign some properties like name, and in this case the name is a list. Bob and Smith. There is a age property, which is numerical. And then there is a bio, which is a method. I know this is a method because I write a function and I declare within the function what I want to occur when this method is summoned. There's another method down here, introduce self. I know it's a method again because there's a function here followed by a definition of what the function will do. Now, I can access either the properties, like I'm showing here on the bottom right, or the methods, like I'm showing here on the bottom right, by using dot notation. And I can set attributes, properties. You can also set methods, although that's a little less common, using dot notation as well. Now, when you create a variable, if it's numerical or string or array, it will come built in with some object methods. And I'd like to take you through a couple of them that I think are useful. The numerical object has many things that you can do with it built in. One of the useful ones, I think, is the toFixed method, which allows you to take a long decimal number like this and convert it to two elements after the decimal point. This is good if you want to display things as an example. The string object is the same way. It has lots of useful properties. For example, you can use the length property to get the number of characters in a string. I could, for example, come to that same example before. Lots of decimal. I could convert it to a string using the toString method, and then take the length property after it's a string, and I would get the total number of digits that we see here. There's lots of other methods that are available within the string object, which I think are very useful. A lot of these are similar to what you will see in other programming languages like Python: include, slice, replace, lowercase, uppercase, and so on. The array object also has useful methods and properties. One of the really useful ones, I think, is map, which does something to each item in a collection and creates a new collection containing the changed items. So as an example, if we had a constant here, cats, it has a list of cats within it. And we can use this map property, the map method, to convert everything to uppercase by simply including the function name that we'd like to use here, and it will convert everything to uppercase as we show right here. Another one of the interesting methods that are available for the array object is filter, which allows you to take, again, something like that cats list that we had before, and to select a subset of it based on some definition that you provide within a function. In this case, things that start with L. JavaScript also has classes and constructors. You can declare a class using the class keyword. For example, if we wanted to declare a class person, we might say that it has an attribute called name. We could initialize this attribute name using a constructor, which means when we are first creating a new person, we would provide the name, and this would be assigned to name through this line right here. And of course, we could have other methods contained within this class, just like we do in object-oriented programming in other languages.